Hey everybody, so I'm going to be doing some frequency measurements on this particular modification, and so I hope that this sort of comes out. I've just got the camera aimed at a frequency counter. First thing I'm going to give it is 10 megahertz. That is from a GPS discipline oscillator. So that's I'm just looking at the frequency counter's internal time base, and as you can see, it's out by 1 hertz, which is okay for what I'm doing. So that said, and that's probably pretty good for the internal time base on a frequency counter, considering that it's not oven controlled. This is just I've been in this counter. It's just a crystal with a metal piece of copper wrapped around it with a transistor bolted to it, and it's one of those deals. So it's like I don't know. Let's see if it's flashing a 2, so it's drifting obviously a little bit. I never turn the counter off, so let's just call it 1 hertz out, just for simplicity's sake, because it's probably like 1 and change, but it's 1 hertz out. So that said, now this is the output of the mod with the SI whatever in the world the number that is. So that's supposed to be 34 megahertz. So if that counter's high by 1 hertz, and I'm getting a 1 flashing a 2 or a 2 flashing a 1, whichever, I'm just going to say that that's 1 hertz out. So roughly a hertz and change. So that's pretty good for something that doesn't have a the SI whatever in the world that thing is. I cannot remember the number to save my life. This I mean, what I'm trying to see if I can't see what it is. 5351. The 5351. It doesn't have a precision time base on it itself, so that's pretty good considering. So, but here's the kicker. So that's supposed to be 34 megahertz. Okay. That's going to go into or replace where the VCO was on the radio. That's going to be the new PLL circuit. That's probably stable enough for a CB. In all seriousness. So let's now go to the CB, and it's not transmitting. So I've got the this calculated so that what I should be seeing is 26.2 megahertz. So 26.200016. Now that 16 on the end, that's probably the 7.8 megahertz oscillator in the radio, because we just measured the new VCO, so we know that that's going to be the 7.8 megahertz. It has to be, because that should be remarkably close. So, and that still is remarkably close. The radio has not been aligned in any way. So, that's pretty good. So if we go to 27.2 megahertz, now we've drifted a little bit more, because you have to keep in mind that this SI board does drift a little bit depending on what you're giving it. So we go to 28 megahertz, and it's drifting up a little bit, but we already know half of that's going to be that 7.8 megahertz oscillator. So this is 29 megahertz, and it's drifted up a little bit more. So now we're 40-ish hertz out, 39, whatever. This is going to be 30 megahertz even, and the radio's output power at this frequency is very low. So I don't know. I'm showing I don't know, 50 milliwatts. It's very low at this frequency. So 45-ish, 46 hertz. That's not terrible. So this is 25 megahertz. I've limited it to from 25 to 30 megahertz. So at 25 megahertz, you can see that this thing is just, I mean, wow. But I don't know how much of that is the I can tell you that that's the SI drifting a little bit and probably compensating for or being compensated by the 7.8 megahertz being slightly out. So because we got to keep in mind that those things, those two, they get mixed together. So at 25 megahertz, you add 7.8 to it, and you can see that we've got, well, that's what I've got on the display, because I'm doing the math on it. So that would be, 25 plus the 7.8, or 32.8. So, and you can see that it's, this is the, once again, the SI board. So you can see that it's a little out there. And then you go to 26 megahertz, or adding, again, 7.8 megahertz. And you can see it starts to get closer. And then now we sort of overshoot a little bit as we go to 27 megahertz and 28 megahertz. I keep saying that because I'm looking at that display, but you got to add 7.8 because it's going to get mixed together. So, it's sorry about that. So, and you see it drifts higher. 29 megahertz, it's going to drift even higher. And at 30 megahertz, yet again, we're going to drift higher. So, I've got to try to see if I can't compensate a little bit in the SI frequency generator. I should be able to compensate for it some, but reality is I don't know how much wiggle room I have in it because I'm not entirely sure. I need to. They've got a frequency or a planner. Silicon Labs has a piece of software that you use to monkey around with this stuff. And I think for grins, I enabled one of the other outputs, and I know that they can interfere with each other. Yeah, see, I enabled the 7.8 megahertz output on one of the other oscillators. So, because I figured that what I might think about trying to do is do both oscillators, and maybe that's the problem actually, because I thought I had better results with it. So I'll probably go throw this back on the computer and go and disable that one and see if this thing doesn't drift back in a little bit, because the outputs are a little funny. But anyway, we'll take a cruise back down and we'll actually look at what we got going on here. So sorry about the ride. Here's the board. Here's the radio. Let me get rid of this probe and see if we can't show this. Alright, so this is what I got going on. I don't know how well this is going to show up on the camera. I hope that you guys can read this. So I've got a span, or an adjustment so you can see what's going on there, and I can vary that in 10 kilohertz steps right now. If you can see the underline that's under there, so that's 10 kilohertz steps. 1 kilohertz steps, 100 hertz, 10 hertz, 1 hertz steps. So, I can pretty much dial in what I want right now. But what I'm not entirely sure about with this is how to deal with the channel selector. What I was thinking about is, depending on where your cursor is, because you know, if I do this, see right now it changes to CB channels. Obviously that's channel 1, and channel 2, and channel 3, and so on and so forth. And it changes the output on the counter accordingly, because that's what it's, you know, the 30 some odd megahertz that's going to come out of this thing. Less 7.8 megahertz is going to be the frequency that's derived. So, you know, so if I turn this, it's going to go back into this sort of VFO-like mode, and I'm not really sure how I'm going to implement that. So if anybody has any ideas about how I could, you know, how I should implement the channel selector, you know, versus the VFO function, maybe they're selectable, but I still want this other knob to be like the clarifier. Maybe that thing should be locked to only vary in you know, 110 or 100 hertz steps. I don't know. Anyway, so you know, any suggestions would be great. So that's pretty much where I'm at with this, guys. I'm getting close. But I probably need to go in and do some software tweaking so that I can get the output, you know, more close to being, you know, on frequency. I'm not worried about the 7.8 megahertz in the radio. That can be tweaked, but the this one's going to be a little bit more difficult to tweak. So, you know, this being synthesized, so that's going to be somewhat more difficult to tweak. So I'm going to have to go and pour into the data sheet again and try to figure out what I could do to get that more stable across a spectrum, you know, a roughly, I don't know, 5 megahertz span. And I'm not even entirely sure that that's really feasible, because this radio, it just ain't going to do it anyway. So if I limited this radio to, you know, say 25 to 29 or something like that, or 26 to 29, I'm sure it would perform better frequency-wise. And the reality is, can people even hear? I don't know. I mean, I would guess I may be able to hear it, and I guess some people would be able to hear it. Can you hear something if it's off by 10 hertz? I mean, you know, I suppose you could. I've never really been able to, I've never been good at telling that. Usually with me and talking on radio, when I did, if I could hear you fine, I didn't really particularly care. As long as it wasn't too Daffy Duck, or, you know, kind of thing, or so on and so forth, then I didn't care about it. It just didn't bother me that much. But, you know, what I'm also thinking about and wondering is if I shouldn't split this apart, because I plan on wiring this, you know, like the old one. You know, this is going to get wired into the microphone, so that it knows when the radio is transmitting and when the radio is receiving. So I mean, I'm cutting into the line, and when I transmit, this knows about it, keys the radio. So that's what this button over here for testing is. And I don't know if that LED is showing or not on the camera, but I got a button over right over here that's simulating the microphone transmit, and then of course you see the LED on the other side. That's the microcontroller. It's also changing on the display, so you know, to indicate that it's transmitting. So, you know, even though on the Cobra 148 you have the green, the red LED, you know, the changeover deal over there, which probably can't see. I can just sort of snake it back out of the hole. So there's the green LED that changes red when you transmit. And you got that, but I've got it on the display too. Maybe it's a waste of time. The display also displays the mode, but of course it's not wired in. Hence the 2 question marks on it, because it's like I'm not getting a mode input. And all that is really the support circuitry is not on here because that's I can't take the 8 or 12 volts or whatever that's being switched when you do modes on this radio and pipe it into the microcontroller. That will do bye-bye death to microcontroller. So there's going to be some level shifting. Just a transistor and some resistors, nothing too fancy, just to pull the pin on the microcontroller low, depending on one of the pins, depending on whether or not we're transmitting, but what mode we're in. And that's only a display. There's nothing really happening there, with the exception of sideband actually on this. The old one, all it did was do math differently on the frequency counter. This one, I actually have to do some changing for sideband. I forgot about that. And I think the cat wants to get up. He keeps rubbing down below. You want to get up? You want to say hi? No? Yeah, he wants to get up. He wants to say hi. Except you can't muck around with the electronics up here. So say hi, everybody. No, you can't play with the stuff up here. You know better. You're not supposed to be here anyway. He just wants to be sociable. Anyways, that's pretty much it. I probably need to go and sit down and figure out the frequency issue, write some code for the sideband offsets, which isn't really that difficult. It just depends on the mode. If we're what mode we're in, we're just going to offset. Anyways, so if anything, when I get the boards, I should have the parts next week, I think. The boards will probably take a little bit longer, but by then maybe I'll have the software perfected, and then I can just stuff a board and flash it and move on. So that's basically it. So I really would like some tips on that display, though, or how that should work with the channel selector and with what's going to replace the clarifier. Like I said before, my initial thought with the clarifier is only vary it in 110 and 100 hertz steps, depending on what you select, and use the channel selector, or have a mode for VFO versus CB. Maybe it shouldn't auto select. Maybe you should pick it. I don't know. Maybe it would be okay to stick to the A, B, C, D, E, F, whatever 40 channel block band plan thing that that was common with like the Galaxy radios. Even though this doesn't have it, the old one did it. You just scroll through the channels and you'd end up in it would tell you A, B, C, D, or what have you. So I don't know. Give me some thoughts, on how that should work. So no, you can't play with that. Stop trying to eat the knobs of the radio. Anyways, guys, so let me know what you think. Suggestions I could really use. So thanks for watching. Catch you later.